Hi everybody, Vanquished Angel here, and today is going to be kind of an old school tip and trick. You can apply it to many different things. This works for Linuxes, but you can take the idea and use it in Windows as well. So essentially what it is, if you have an older computer or even a newer one, using the expansion slots for something useful. So this is my original computer that I first built, my first desktop that I built. And I had given it to my mother because, you know, it's very, very old, very dated. This is a HP DC 7100. My mother used it to play basically games on Facebook or whatever. It was oftentimes slow, so I had to come up with some other ideas to speed it up. And one of those great ways to extend the usefulness of a computer is these slots here. And there are some things that can work with any computer, even a new one, if you have those slots in it. And so with Linux, one of these ideas was a RAID controller card. And the reason why I would do that is because you can transfer the swap space off the hard drive onto the RAID controller card. And this way, you know, you basically have less traffic going to the hard drive to and from. And this would speed up that performance that way, but not only that, but the RAID controller cards are oftentimes faster than the hard drive as well. So they won't be as fast as RAM in the case of swap space when you run out of memory. Linux is used as swap space, similar to like ReadyBoost on Windows, which you could probably also use this idea for ReadyBoost as well. And so you can get, like in this case I have this Silicon Valley or Silicon Image RAID controller card for compact flash cards. And in this case I have 4 GB cards in each slot. So there's 8 and this is 16. So if you put this in the computer, and I'll go through kind of how to do that a little bit, but if you put this in the computer and you set it up for swap space to be on here, it should be faster. It'll also be faster because depending on how you set up the RAID, each one of these cards has their speed, their throughput. Now one card is slow, but the combined speed of all 4 will be faster than your hard drive. Improve performance of the swap space when the swap space is in use. And now once we're doing this with that RAID controller, we have to boot up the computer. And then, so gotta wait a little bit. We gotta hit F3 to set it up. And so we are going to F1 because I have a set in there. So we're gonna delete it. Yes. Okay, so then we're gonna hit F2 and we're gonna create RAID set. Alright, and then my selection is going to be a stripped set, so F1. And then we're gonna go 9, 4. We're gonna go 1, 2, 3, 4. Oh, and 0. Yes. So we're gonna have to go by these numbers up here. So it's 0 instead of these ones. We're gonna go by these ones you see up there. And then we're gonna go yes. So I chose to do 0.5 megabytes, if you see at the end there. 0.5 megabytes per block, I believe. You could also choose auto. And then, yeah, sorry about the flash, that light there. So then we're going to say yes. So we're going to create that. And we got it. So we're going to hit escape now to exit the RAID configuration utility. And then we're going to boot into Ubuntu. Alright, so I have rebooted the computer, and now as you can see, these 4 compact flash disks are seen in Ubuntu, and they're just not formatted. The RAID we set up earlier doesn't seem to be recognized from the BIOS. Maybe it's just some weird setup or something. Who knows? But it doesn't seem to be seen, but that's okay. If it was seen, bonus. If not, still okay. We can still use it for the same purposes. So this is the disks utility. As you can see, it's there, and they're not formatted. It's all unknown. So we're going to close that. Then this is sudo fdisk. So now you can see that we selected that 512 bytes or whatever is the units or sectors. I'm not sure if the half megabyte applied. Probably did. That's probably what that is when we set it up in the BIOS there. And each one has a different hard drive name there. So we are going to go into gparted here, and we're going to create a new partition table. So we're going to go device, create a partition table, MS-DOS, yeah, apply. So we're going to do that for each of the 4 drives. Then we're going to go back up, new, we're going to use the whole thing, and I'm going to do an extended partition, and we're going to add, and device, then we're going to create new Linux swap, add. And so we're going to do that for each. Then we're going to apply, and this will probably take a little while. I'll have to edit a lot of this out. What we're going to do then is, after you've gotten your swap space formatted, and you've got it all set up, so in this case we're going to go up to here, you're going to need to know the UUID. As Linux uses UUIDs now, it used to use the hard drive name, but now it uses UUIDs. So in gparted, we are going to go here and information, and the UUID is right there. So it's not active at the moment because it's not mounted, which is a good thing for this time. And then, you know, if you're doing the compact flash thing, each one, but make sure you're clicked here, because if you're clicked on the extended, then the information will not show any UUID. So you have to go here and information, and then it shows the UUID. Another way to get the UUID is from the command line. So in this case, we're going to go here, we're going to open that, and it's going to be this command, the sudo blkid /dev /SDA5 in my case, but it's going to be that path of where you have the swap space. So we're going to hit enter, and I'm going to put in my password, which you cannot have, and then the UUID, and it should match this one right here. And then it gets the type, which is swap space, and then I don't know what that other number is. I suppose I should probably know in this case. So that's how you get the UUIDs. So now what we're going to do is we are going to put that in our F stab. So we're going to copy, open, paste. Now you see the UUID of one is in there and how it's written in there. And then there's the UEFI. Excuse me. And then the others. We're going to add more. So we're going to hit enter. And then I already have all the 4 ones added on. So we're going to copy. And we're going to enter those into here. And I like to just even stuff out as best as I can, and then we can put a little note in here in case I have to come back to edit this. So we're going to pound sign, and then we're going to put added swap from compact flash. And then we're going to save that. So now what I've done is typed in swapon -s, as you can see right there, SWAPON space dash s, and this will give you some information about your swap space. So I have my original swap space, which is dev SDE3. Now you see that that has changed. Swap was on dev SDA3 during installation. That's because we added the compact flash and they added first. So excuse me. So they took priority, but the UUID has stayed the same. So the swap is still correct there, and it still registers, and it comes up with a different one, but it's still correct because it uses the UUID. And then we have the priorities here. So you can see the priority of SDE3, or my original swap, is -2. And then the priority of my ZRAM is 5, which means my ZRAM is going to get used first. For this one, we're going to uncomment now this line, or we're going to put a comment or pound sign in there. The reason why we're going to do that is because upon booting, Linux will now ignore that one. Since I have other swap space, that one can get ignored, but I'm going to leave the comment in there because in case I want to undo it. I really don't have a need for swap space on the hard drive, but just in case. So then we're going to save this, and then we're going to close that out. And we might come back to that to set the priority. And I will show you how to do that after a reboot. Alright, bye. Now I have rebooted, and as you can see, I ran again swap on S. I'll say used at 0. I have more than enough memory to boot. What we have here is then it automatically sets priorities for each of the swap spaces that we built. So the one with the highest priority here is this -2, then comes the -3, then the -4, and then the -5. And ZRAM has the highest priority. So we are going to learn to assign priorities to the swap spaces. Okay? Okay, and we're back. So now we're going to set the priority for the swap. And so what we're going to do is we're going to turn the swap off. So we're going to have to open another one. And might have to be a sudo command, so I'm going to take that and paste. Okay, so now swap should be off. And then we're going to set the priority to 100. Then we're going to save. And then we're going to turn the swap back on. So that's swap on A. Paste. Now the swap should be back on, and so we're going to go swap on -S. And now we see the priority has changed. So I'm going to reboot and I will be back. And we have rebooted, so now we are going to check our swap space here and see how that is going. The command is swap on -S, and there we are. So we're going to be using those compact flash disks first before my compressed or ZRAM. Now ZRAM is awesome, not berating it in any way, but what would the benefit to this be is if you have a weaker processor, ZRAM requires more processor cycles. So on an older computer, it's kind of a hit or miss on whether or not it's beneficial. I almost always found ZRAM beneficial, but in this case, in my desktop, I can use compact flash and it'll work just fine as swap space. So there's an idea for you guys. Alright, thank you very much.